Welcome back to ASIB. Today we're going to be talking about logarithms. So first of all, let's talk about what logarithms are and why we need them. So recall from our powers that if we have a to the power of x equal b, we want to somehow solve for x. Now this is different than the linear or quadratic equations that we've covered already, because this time x is in the exponent. So how do we solve this? Well, to solve this we need logarithms. In general, we write this as x equals log a b. And you can say this is the logarithms of b with respect to a. Now here, a is called the base. So whenever you see these two, you know they're interchangeable, which means if one of them is true, then the other one is also true. So now let's look at some logarithm laws. First of all, recall from our powers that if we have a to the power of x plus or times a to the power of y is equal to a to the power of x plus y. Remember how exponents can be added when they're multiplied? Well, that kind of applies the same way when we're doing logarithms. Basically, if we look at the exponents, we have that we can write this using log AB, then we have log AB plus log AC equals log ABC. I'll write them in brackets so that's clear. When we add logarithms that have the same base, we can essentially multiply the numbers. Similarly, if we have log AB minus log AC, then it would be the same as division, or log A B over C. So next I'm going to show something that is generally not taught in school, but I find extremely useful when you're doing log problems. So I'm going to share it here. Now this isn't on the formula sheet, so write it down or remember it if you have to, but it's not too hard to remember. The question, or this log law goes like this. So if we have log ax, right, and we want to change it to a base, and oftentimes you're going to get logs in base 2, you're going to get logs in base 4, you're going to get logs in base 8. And sure, you can go through the base change formula, that works, but sometimes I just find it easier to just use this formula. Log ax equals log a to the b x to the b. Now see, this b, the exponent is acting on the a, and this b is acting on the x. And we can even go one step further. Remember, when the b is on the exponent, we can write it like this. X. So if you want to change something, let's say log 2x, and we want to change that to base 4, well, we can square both the base and this, and we get log 4x squared, which is just 2 log 4x. Similarly, this also works if you're trying to get from, let's say, log 8x, and we want to go from log 2. Now, it might seem a little confusing at first as to how we can, take a power from 8 and get to 2, but we can actually take a power of 1/3. So if we take a power of 1/3 on the 8, and also a power of 1/3 on the x, we get that log 2x, 1/3 log 2x. So this is something that I find extremely useful, that I mean, I just find it that when I'm simplifying logarithms, especially if the bases are powers of each other, like 2, 4, 8, 3, 9, 27, I just find this a lot faster than using the base change formula. But, of course, both methods work, and we're going to see an example coming up where you do have to change bases. Okay, now let's take a look at some more power laws. So, if we were to write out that last law that we just talked about many times, so log ax plus log ax plus log ax a bunch of times, and let's say we added them m times. Oh, it's a bit big. Go. M times. Well, we can rewrite this as m times log ax. Right. So, actually, let me put this up here so we have some space to work with. Log ax m times that equals this. And therefore, remember, when we add logarithms with the same base, we can essentially multiply the numbers. So therefore, we're going to get log a x times x times x. And that is n times. And therefore, this is going to be equal to log a x to the n. So, writing that out over here, we have m times log ax equals log a x to the n. So this is a very important power rule that no matter what you're definitely going to need to know. And knowing how it's derived will deepen your understanding about logarithms. Okay, so far we've only worked with logarithms that have the same base. We know how to add them, we know how to subtract them, and even if there's a bunch of them added together, we can even lower that exponent into a coefficient. Now, let's talk about what happens if the logs are not in the same base. Well, there's something called a base change. It's not a function or an algorithm or a theorem or anything. It's more of just a common thing that you should know. Normally, to be honest, I don't use this formula when I'm doing my problems, but it's definitely something that you need to know. So, the base change formula goes like this. This is straight from the formula booklet. So we have log ax equals log bx over log a, or log ba. Essentially, the logs just kind of cancel out each other, and then the a goes into the base to form log ax. You can kind of see how that works, right? Another way we can represent this, which might make more sense, is if we multiply log ba over to the left side, we get log ba times log ax equals log bx. And from here we can kind of see that a times log a kind of cancel each other out. Now, there's no operator here that you can actually say that they cancel out, but you can see they kind of do to get log bx. So, not really an operator that you should remember this way, but if you ever recognize log ba or anything, log a times log a x with a base a, then just know that you can cancel them out, and this is very useful. Okay, so now let's look at a quick example. Let's take a look at this equation. Log 5x plus 3 equals negative log 25x. So first of all, we see that log 5 and log 25, they have different bases, and we can't really do much with that. So first of all, let's do a base change. Now, one thing we could do is we could change them both to base 5, but in this case, I'm going to actually change them to base 25, and I'll show you why in a second. So, with this side, we have log 5 squared equals, or log 5x equals log 5 squared x squared plus 3 equals negative log 25x. And therefore, we have 2, moving this 2, the exponent, log 25x plus log 25x plus 3 equals 0, moving the log 25x over. And therefore, we have 3 log 25x equals negative 3 log 25x equals negative 1. And therefore, x equals 25 to the power of negative 1, which is 1 over 25. So, that's it for log laws and an introduction to logarithms. I hope you enjoyed this video. If you did, please leave a like, subscribe if you find our content really helpful, and if you want to see more of this in the future. If you have any suggestions for what topic we should cover next, you can drop it down in the comments below. Thank you for watching.